Hello, everyone. So, we're going to talk about object oriented programming today. Um, object oriented programming is a really important concept in computer science, and it's something that you will be delving into in great detail in your CS 112 class. It's not, it's beyond the scope of this class to go into it in great detail. Plus, Python was, it's not the best programming language to learn object oriented programming in. You're much better off working with a programming language that was designed specifically for object orientation, like Java, which you'll be using in CS 112. But because this is an intro class, I do want to introduce you to the concept of it. Just very easy beginner's version. And then at least when you start CS 112, then there'll be a little bit of background there. It won't be a completely new concept. So object orientation is another one of these CS concepts that takes some time to get your head around. And it's totally fine if it takes you a whole semester for it to really click. So the idea with object-oriented programming is literally in your code, everything is an object and it represents something, in the real world or something that you're trying to represent in the code. So this cartoon is a really nice, I think, example. The world seen by an object-oriented programmer. So, for example, the blinds are called a privacy manager delegate. The TV is an entertainment provider singleton. The cup is a thirst quencher container, and all of these objects in the room will be objects in their program. Now, so far, you have been using procedural programming. So procedural programming, is specifies a procedure or a function or a method. What steps to do in what order. So you've been writing functions, and that call each other. So you write a main function and that calls other functions. So you've been working with procedural programming. So object-oriented programming specifies what objects exist and what each object can do. So we're going to look at that in greater detail in just a moment. And we mix these two styles of programming. So we're still going to have a main function to create objects and tell them what to do. So the thing is, we've actually been working with objects all semester. It's just not been something that's been entirely clear. So for example, when we covered file input output, if you remember, I said, this is an object when we had that file variable. But I said you don't need to worry about that. So, when we had, for example, file open, and then we would open a file and then we would say read or read line or read lines and so forth. We would say dot, right, to some variable, and that was an object. We also looked at strings, and strings are objects in themselves. So for example, we would say, string dot strip, or, you had a variable name dot upper or something like that. We also had that with lists and dictionaries, but I don't think it's super helpful right now for you to understand why these would be objects. So let's look at it in a really simple term. So let's imagine a house, right? And we want to write down what are some parts of a house. So let me get my tablet. So we're saying, like, what are some parts of a house? So if we were there in person, I'd be doing this interactively, but we're not. So here are some examples. We have some windows, doors, and maybe some plumbing. So let's go here, and we could say, oh, let's fix that, make that brighter. So we have some windows, doors, maybe some plumbing. Obviously, a house has other nouns and other parts of it as well. And then after we've, list a few parts of the house. We want to figure out, what do the parts of a house do? So for example, the windows can open and close, the doors can open and close, and we can turn the faucets on and off. So we could say open, close, open, close, turn on and off. Okay. So you can think of the nouns that we've listed out as variables, and you can think of the verbs that we listed out as functions. Now, I'm going to come back to this slide in just a moment, but when we think of objects, rather than variables, the official term here, I'm going to call it an attribute. So if you look at this slide here, an attribute is a variable attached. This is going to be confusing, to an instance. Don't worry about that right now. And rather than a function, we're going to call it a method here. Right? So you can think, for example, if we were trying to represent a house in a piece of code, it would have some nouns like windows, doors, and plumbings, and these would be considered attributes of that object. And then here we have some methods to go with each of these. So we would have open, close for windows, open, close for doors, and on and off for plumbing. So now let's go back to this slide. And an object are just related nouns and verbs packaged together. So this whole thing packaged together is considered an object. So in this case, in this example that we're doing, this is considered an object that we're building, like a house object, right? We're trying to represent a house in code, and a house would have, windows that open and close, doors that open and close, and plumbing that turns on and off. Obviously, we would have other things, like we could have the number of windows, we might have roof, foundation, and so forth. Okay. So yeah, let's come back to this in just a moment, but you'll see the term instance being used, and right now you can think of it in terms of an object, like an instance of a class. It's a single specific example of a class. We'll come back to what a class is in a moment. As we said before, when we're using objects, we won't use the term variable, we'll use the term attribute. So that's why we have attribute here. And then we'll use the term method instead of function here. So now let me just do this real quick. So this is an example of an object. So say we were having a house, doing the house example. Then what we would have is we would have a class for a house. And you can think of this like a blueprint. So literally, when you're trying to build a house in real life, you have a blueprint, right, to how to build that house. That blueprint is not a house, right? It's a template. Let me put it here. It's a template. But from this template, you can build many houses. And similarly, from this class house, you can build many objects. So I could do house 1, could have house 2, have as many as I want. And these could all have different, attributes. If I had all these different attributes, like some could have red doors, some could have green doors, some could have, 5 bedrooms, some could have 2 bedrooms, and so forth, depending on what my template is, right? So when we look at this slide and it says a class is a template with nouns and verbs, it's just think of it like your blueprint. We're going to have a look at example in code in just a moment. But then from that class, we actually have to create objects. And in Python, well, in general, the way we create objects is through a constructor, which we'll look at. But in Python, the way we create objects with our constructor is using this keyword, underscore, underscore, init, underscore, underscore. It's short for initialize. So, you'll come across constructors in Java and C++ and C# and so forth. This constructor is more specific to Python. Don't worry about the self. You don't need to worry about that here. Okay, so let's have a look at an actual example. So we're not going to dive into great detail with the code in Python because it's a little bit, complicated and it's not super helpful for the translation into Java. So we're just going to have a look at this class just to give you a little bit of an idea, but you're most welcome to dive further if you wish. Okay, so let's look at this class house. So don't worry about what's below the class for now. We're just looking at the class itself. So remember, this is the equivalent of this template here, up here, this class. Okay, so here is our constructor. Don't worry about the self. It's okay. And we're going to have an attribute n underscore windows. So that's going to be the number of windows, and it's been hard coded to be 1. So whenever a house object is created, they will have 1 window. And window underscore status. So it's going to be hard coded to be closed. And then here is a method, open window, and we're going to say window status equals open. So you can see that this is a really, really simplistic class. We have 2 attributes, n windows and window status, and we have 1 method. And it is a house with 1 window that starts off as being closed. And there's no door and no roof and who knows what else. And then what we do here in line 10 is this is where we actually go ahead and instantiate an object. This is where we create an object. So we say my house, so this is a variable, equals house, like this. And we capitalize objects. And so here you can see we're creating, so this is where we say we're creating 1 instance of a house object. And then we're going to, so this, because this is our object, my house, whenever we right now are going to call one of the attributes or methods, we're going to say my house dot. And you did something very similar, when you did randint, you would say random dot randint, right? So here's similar, you're just creating your own class this time. So you say my house dot, and then you're going to print your window status. Then you're going to call your method, so myhouse.openWindow, and then you're going to check your window status again, and then you're going to print the number of windows that you have. So if we go ahead, and let's make this a bit bigger. If we go ahead and we run this, so you'll see that the first print here with the window status, it shows that it's closed. Then we call the open window function, so then it should be set to open. So when we print it again, now we see that it's open, and then we look at the number of windows, and there's 1 window. This is really the tip of the iceberg, and then things get a little bit more involved as you go along. So I think this is a good starting point. There are other things like getters and setters, which are called accessors and mutators. And I think, and there are some differences between Python and a language like Java that is object-oriented designed. So I think what we'll do is we'll stop here, and this will give you a bit of an idea. There's no homework for this. This is just a little gentle introduction. But if you want to, you can dive further into the Gaddis textbook on this, and this will be the focus of your CS 112. And it's always good, if you want to revisit this lecture in the future, you can always it's always good to hear the same concept from different sources and talk about object orientation, which does, like I said, take a little bit of time to sink in. But once it sinks in, you'll find yourself thinking about things in terms of objects. And if you're programming a video game or something, it's made up of many, many objects. You might have a character object, and then that character, you might have the hair object, and you might have the clothes object, and so forth. So it's yes, it's a whole world. It's a whole world which we're doing a very, very short intro to. But it's something I hope that you get into and enjoy. All right, so we'll leave it here for now.